Thank you for watching Knowledge Academy. All right, so in this chapter, we're going to talk about measurement. Before we start this topic, let's talk about in general, what is a measurement? And just so you know, many things in our surrounding and society has to be measured so we can deal and convert and exchange between parties, between people to party, party to people. So in general, the thing is that if let's suppose you want to buy fruits, right? Fruits came into you make pay money, right? So dollars. So if you want to buy fruits or grocery, if you want to buy anything like any other material, let's suppose you want to buy copper, you want to buy steel, you cannot buy those things without a particular amount of quantity. So let's suppose you want to buy banana. You cannot say that I want to buy $1 banana. You have to specify how much banana you can buy for $1. It means maybe you can say $1 banana is going to be one banana. Okay. Or you can say it's $1, or I can say it's $1. I got two oranges. Okay. Same thing if you want to buy copper or copper wire more specifically. So let's suppose you have a copper wire, you get and then the unit if you want to sell it, you can particularly define the unit. He says, maybe I want to buy $2 per meter. Right. What is this meter? And what is this two oranges? This is a quantity. This is a quantity. But here, this meter is not a quantity. Meter is basically something outside the number of like two bananas, two oranges. They are considered quantity. It's easy to measure. But we need another unit of measurement, which is called length. So we use meter. And meter is certain size. And we say from here to there is 1 meter, and here to there is 1. So if you add one on one, it becomes okay. Now, in order to be consistent, different part of the world, different kind of parties, different kind of dealing with the businesses, dealing with the residential purposes deals, we have to make sure everybody dealing with these units consistent. So what we did, we just basically say units. And what is a unit? Unit is something we measure things, we quantify them. Those are the measurement. For example, we measure the length in meter, millimeter, inches, kilometers, and miles, etc. There's so many others like feet and yard and stuff like that. Other more popular unit we use is for weight, right, or mass. Mass means how much material do we have inside the object. So let's suppose you go and buy the, you know, a watermelon, and watermelon size is maybe 8 pound, right? So usually we use the units for weight. We don't call it mass, we call it weight, and we use more popular unit is pounds, kilogram. There are other units are called ounces, stuff like that. But we're gonna stick like a general, very popular one, pound and kilogram. The other quantity which is we use to measure is right, like your exam is 2 hours, and it's gonna take 3 hours to finish the movie. It's gonna take you 15 minutes to walk from your home to the store, stuff like that. So time is also being measured, and we can use a unit. And we are lucky enough, we don't have a bunch of different units available for time. We usually use second. And sometimes if you have a time is very small, we use millisecond. And second, we usually use second. We don't write the complete word second. We just use S. Okay. And millisecond, we use ms. So bottom line is that these unit is used to measure things from So we can quantify, we can sell the material, or we can say that I'm going to meet you at this time. So we can quantify, okay, I'm going to meet you at 6 p.m. And maybe I can say I can meet you at 2 hours from now. So these things are being used to quantify these quantities. Now, another thing before we move forward, these are the basic thing we used in our surrounding: length, mass, and time. Everything else coming out of these. So we call these three number one, number two, number three. These are our basic units. In fact, everything else we talk about in physics, in chemistry, in math, or any other quantity we talk about that derived from one of these units. Derived means is basically like a chemical, right? Chemical have chemical composition, or you have a medicine. Medicine have a bunch of ingredients. So these are the ingredients of units. These are the basic ingredients of units. You mix and match to produce different kind of subunits or derived unit. You can call it derived unit, just like ingredients. You have ingredients for food, you have ingredients for medicine. So you can mix and match these ingredients to make different kind of food, to make different kind of medicines, make different kind of chemicals. And these ingredients, in terms of here, we call them basic units. Okay. In this chapter, we're going to be talking about SI system. SI system means System International. So what they do, rather than everybody saying, I'm going to measure the length in inches. Somebody says, I'm going to measure the length in millimeters. Somebody says, I'm going to measure the length in miles. What they did, what they just standardized. And SI means System International. So we're going to be talking about that one, S1 units. So S1 units are, for length, we use meter. For mass, we use kilogram. And for time, we use second. These are the three SI system units for basic unit system. Okay. Just like I mentioned to you, a unit is a unique name assigned to measured quantity. And we have mass, we have time, we have length. We also have pressure, we have force, we have a velocity. But the thing is, this, this, and that, all three, length, time, and mass, are considered as a basic. Pressure is a drive. What is pressure? Pressure is nothing but it's basically force over area. And what is a force? Force is another quantity derived from other units. Area is another quantity derived from other units. So you can talk to them, but this is not, pressure is not considered as a basic units. So the basic quantity, we already talked about that. There are 7 fundamental quantities such as time, length, and when we consider them, 3 needed to be a mechanics, length, time, mass. That's what you're gonna talk about in this chapter. These are the 3 quantity out of 7 you're gonna be talking about in this chapter. Okay, we already speak about that. What is SI? Base unit, including length, time, mass, and we have a derived unit. Derived unit means like I can take a little bit this, and then add them together in a certain ways. So I can call them something, something else. So you can say here, there is a derived unit called joules, energy, and there is a watt for power. Okay, so these are the derived unit. These two are derived. But if you notice one thing, if I'm talking about these derived unit, we can say here 1 joule equals to 1 kilogram meter square per second square. So see here, we take 1 m, 2 L, L means length, so 2 units of L, 1 unit of m divided by 2 units of time, which is second square. So mass, or m, is considered mass, L stands for length, and T stands for time. Okay, so that's why how I derived it. Same thing here. 1 watt means joule per second, so joule is equals to 1 kilogram meter square divided by second cube. So you see here we have a 3 time units, 2 length unit, 1 mass unit. Just like I mentioned to you, if you're making a different kind of chemicals or food, what do? You mix and different kind of mixing different ingredients. But what are the ingredients? These are the ingredients. Oh, those are the ingredients. Okay. Sometimes we have a small unit like this one, or sometimes we have a big unit like this one. So small unit, let's talk about the big unit. If somebody's writing like this, it's very hard to write like this. So what we do, we just use the exponential form. In our calculator, there is a button called E and G engineering thing, and there's a little arrow on the top of it. What does it do? What it does do? If you're writing some big number like 183529013 and hit this button actually moving this number into some sort of this form, right? Or that form. So you can see here, I can take calculator. If I put into the calculator, they move it. So this unit, there is a decimal here. So it can be moved 1, 2, 3, 4, 5, 6, 7, 8, 9. And I just what I'm going to do, I'm going to write the decimal here and says 3.9 to the power, move 9 times. So I'm going to say that. Okay. Same thing if I have a decimal on the other side, it looks like it's a very small number. So I can move this one 1, 2, 3, 4, 5, 6, 7, right? Just do 7. And I'm going to write 4.9 to exponent 7. But since I move towards the right, if I move towards the left, I use positive. If I move towards the right, I use negative. So I use negative. And second is second, so I'm writing a second. Same thing, meter is meter, so I'm going to write in the meter. Okay. Now, since we know all the basic units, we also can convert the units into different kind of conversion between one unit system to another unit system. And the great example is that somebody says, how many seconds do we have in 1 minute? 60 seconds equal to 1 minute. So if someone asking you that, suppose, hey, how many seconds do we have in 2 minutes? So what you're going to do, you're going to take 2 times 60 is going to say is 120 seconds. So you can say that 2 minutes equal to 120 seconds, right? I use the word s in second. And that is basically how we do the conversion. So we use different kind of ratios to convert one unit system into another unit system. And these ratios are used to convert unit system from one system to another. Okay. Yeah, this is basically a example of how big is the unit system. So long time ago in Sensia time, this is basically you can see there is a window and then this is the size of the 1 meter, right? This is a 1 meter. This kind of a brick slab is basically used for 1 meter length. So there is a history involved in the Greek time period or Greek time frame. So Greeks and Romans are the one who developed these meter system, or basically considered meters. How big is the meter? So you can look at the book if you want to read, but this is not important. What is the unit? What is a meter? How big is a meter? Maybe somebody just go a long time ago and then taking a statue and measure the feet of the statue and consider them as a meter. And that meter or maybe this little slab in the wall or the block in the wall, they consider as a 1 meter. So they use this as a standard. And since it was done very long time ago, so nobody argued that one, just people just adapting, people just adapting this assumption and then keep using that one. Okay. So I'm going to be just talk about jumping into unit system. Right after I talk about unit system, I'm going to be talking about significant figure. What is a significant figure? Significant figure means significance. The word significance means important, right? Just like we know, significance means how significant effect of something. So significant means important. So the basic idea of the significant means is that if I'm writing just like 1.01 or 1.00, there is a difference, this one have some reason. So if I'm writing 1.00 or 1.000000, like these two are pretty much same, right? But this is not. So this is something different about this, the way I'm writing. So if I'm writing 1.00 or 1.0000, these both are pretty much same, just I'm just not doing anything. But if I eliminate the last digit here and putting a number here, now you cannot write this guy, you cannot write this number like 1.00, or you cannot write just one more zero. No, you cannot do that. There is a reason somebody writing this 0, 0, 0, 0, 0, and then 1. It means this is a really important number. So little bit changes in this number, even for a very minute level, they're gonna produce some effect, right? So if I'm selling you gold, and I says I'm gonna sell you gold for $2,000, I'm gonna sell you gold, and how much gold you're gonna buy from me? You're gonna buy 1.9342865 kilogram. That's suppose I sell it. Since gold is very precious metal, it's very expensive, and it's a very valuable, right? So let's suppose if I'm saying that, well, pay me $2,000, but I'm not gonna give you the whole gold like this. I'm gonna say, well, there's so many number. Let's make simplify. 1.9 kilogram. I don't think so you would be happy to take this deal because I ignore this number. And this number mean a lot because I'm not gonna give you this gold, but I'm just making assumption. So you're not gonna be let me to make this deal because this deal is not gonna make a good deal for you because I'm making a wrong assumption. I'm ignoring this big number, which should not be ignored. And that is actually what significant figure means. Significant figure means if you want to emphasize on certain numbers, you putting them in your calculation. Okay. Okay. So, but sometimes these numbers are not meaning a lot. For example, here it was stated in the newspaper that attendance of Melbourne Cricket Stadium for a football match was 64,000 people. Actually, 64,000 people watched the game. That's coming into the news, like how the newscaster making this announcement. But the thing is that the actual number who was somebody actually counting the people, number of people over there is not actually 64,000. It is 64,492. But think about it, just like a common sense. If you are reading or if you're watching a news and the newspaper or the news article says there was a cricket match or there was a football match and inside the stadium is a huge crowd, it has 64,000 people watch the game. But actually, they basically, this is round off. This is a round off. Okay. In reality, if somebody coming from number, it was different number like this number, 6445. So remember, this is not a goal. You can round off this one because there's not going to be these numbers like a 492 is not significant. Is not significant here. So that is the significance whole purpose is that sometimes the numbers are significant, sometimes they are not. So I can round off because it's less than 500, which is less than 492 is less than 500. So what I'm going to do, I round off this to 0, 0, 0, and I call them 64,000. Does the meaning is changing? Not probably not changing. Okay. So let's take a look into these examples. What is how many significant figures do we have here? Is somebody writing like that? The most accurate answer of this is given by 5 significant figures. What is the 5 significant figures? Figures means digit. So count here. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and there is a dot here. So maybe you can write this called 6, 4, 9, sorry, 6, 4, 6, 9, 2, dot. And so how many from here? 1, 2, 3, 4, and then 6 is 5. So there is a 5 significant figure. How many significant figure here? Really, those are not significant. I mean, you can ignore them, right? Because they are 0, 0, 0. That's why it is not there. So you just leave it there. So you can round up, really. So 64 is there. So you can write 64, 0, 0, 0. You cannot change these 0, right? You cannot add another 0. But it's not gonna change the meaning. But if you erase this 4 and make it 5, yeah, that's 65000. It's making a big difference than this one. So you cannot do that. It means only two numbers are significant here. All, not all numbers, 000 are have no meaning. So really they are 0. But 6 and 5 or 6 or 4 have meaning. So these two digits have meaning. So it means is that if you change those numbers, it's going to change the meanings of this number. So 64,000. And if you want to write 65000, it means 65,000. So 64,000 and 65,000 are not same. It means you cannot do that. Okay, here. So how many significant here? So you cannot change them here. So 5 and 4 are significant. They are just basically, they have no significance. You can call 0, 0, 0, 0, and 5, 4. But 5 and 4 here are significant, means they are important. So if you want to change this number, let's suppose you're going to write off 5 and 4 and says, I'm going to round off to 0. No, you cannot do that because 5, 4, and 5, 0 means something. Sorry, my 0 should be, my decimal should be here. So 5, 4 is basically significant here. Same thing here. What are the significant? 3 is only significant here. So 3 significant figures are this, 3. All 3 are significant. Okay. Because you say 3.20, so you cannot ignore anything outside the decimal to these two, and then you cannot ignore the 3 because it's previous that decimal, so you're going to be writing like this. 0.50. How many significant? This one is significant, yes. This one is significant, yes. You cannot write this. No, you have to write like this because somebody writing like this way. So it means 2 decimal places. Remember, sometimes usually when you are in high school, you do the math question and the instructor or your teacher asking you, please include in 3 decimal places or 2 decimal places answer. And that's why, because both they are significant. So they know that your answer is correct or not correct. So this is exactly the same example here. So we need to include both. So it means significant figures are 2, 5, and 0. Both are significant figures. Okay. Now let's talk about some calculation. So we have some standard ratios to convert, length and to convert time, to convert weight. And these are the ratios that we have here. So if you want to convert from millimeter to kilometers, what we do? We're using kilometers to meters. So kilometers, you want to convert into meter. So what you do, you say is 1 kilometer. Kilo means 1,000. So you say is 1 kilometer equal to 1,000 meters. So if you want to leave the meter here, if you want to leave the kilometers here, you're going to take this one on the other side. So it's going to be kilometer equal to 1,000 divided by 1 meter. Right? So this is the ratio. This is the ratio you got. That is a ratio you got. So if I'm asking you in this question, in this first problem, asking you how much meter do we have in 1.3 kilometers? So what you're gonna do? You're gonna take 1.3, right? Multiply the ratio. So what ratio is 1,000 over 1? So what is an answer? You can also write this thing, and this is the answer. Same thing if you want to convert the kilometers into centimeters, so you know that kilometers to kilometers ratio is this, and meters to centimeters ratio is this, right? So you multiply them, so so twice, you're going to be taking twice ratios multiplied by 2, and you get this one. So let's take a look at the examples. Example. So 1 mile equivalent to 1609 meter. So we need to find, so 55 miles per hour equal to what? See, mile per hour. I can maybe write it miles per hour. Or you can also write miles per hour. Okay. So what you're going to do, you're going to multiply miles per hour. So you're taking what we're learning here. The solution is 55 miles times multiply by this, because they are meter. So we can maybe we just do this one for the sake of simplicity. We're going to be doing this. We're going to say 1 mile equal to 160. So if I'm going to multiply this by 55 miles equal to 1605. So 1609 times. Okay. And it gives me some answer, and the answer will be meter. And after I get the answer, I'm going to say it's miles per hour. And I'm going to convert it to meter per second. So I'm going to take 55 miles per hour. So in there is in the denominator, there is an hour. I want to convert this hour into second. So I'm going to take this hour and multiply by, let's say, I want to convert this into, if I divide the two, then my answer, I'm going to get it 4.6 meter per second. And that is my answer. Take a look at another unit conversion system. A 2.75 meter by 3.50 meter plate of aluminum has a mass of 616 kilogram. What is the thickness in centimeter? Of the plate? Okay. And there is a note is given. No, the density of aluminum is 2.70 exponent to the power 3. And there is a unit kilogram per meter. So this problem, just pay attention. A 2.75 meter by 3.50 meter plate. So let's suppose this plate is given like this. This side is 3.5 meter. This side is 2.75. Okay. The weight of this plate is 663, and the density is. Okay. Now, the height of this plate or the thickness of this plate, I don't know, so I'm going to call it x. So let's do this problem and let's see solution. We know density equals to mass over volume, m over v, mass over volume. The mass is given on the plate, which is 663 kilogram. Volume of the plate is not given, but we know volume over v equals to length times width times height. So here the length and width are given 3.5 and 3.7, so 3.7 times 3.5 times x. Because height is not given, h is converted to x. So what you can do, we can just substitute the formula. Intensity is given 2.70 times 663 divided by the volume is 2.7 x. What are we going to do? We're going to take the x on the other side and leave everything else here. And then bring this 2.7 in the denominator. If you take in the calculator and substitute everything, you're going to get the answer. Volume or x equals to 2.55 meter. Since in the problem we're asking the thickness in centimeters, so what I'm going to do, I'm going to convert this meter into centimeter, and we know meter equals to, I think it's going to be, if you multiply, it's going to be answer 0.025. And if I want to convert centimeters, so we know 1 centimeter, or I'm going to say 1 meter have 100 centimeters. So I want to convert this. So what I'm going to do, I'm going to just multiply this by 100. So if I take this guy and multiply by 100 to convert it to centimeter, the answer x is equal to 2.5. Take a look at another example. Problem. A free Freely falling object required 1.40 seconds to travel the to travel last before it hit the ground. From what height above the ground was it dropped? Yeah. So in this problem, we're going to solve the problem. In this problem, we have initial velocity 0 because it's freely falling. Acceleration equal to minus g. The acceleration due to gravity equals to minus 9.8 meter per second squared. We're going to be using this formula. Okay. The height is given 32. So I'm going to say is 32 with minus sign because it's towards downward equal to vi. Time is given 1.4 seconds plus half, and a becomes 9.8 g minus sign, and then 1.4 times 1. You solve here, you're getting the vi equal to, which is your initial velocity. Now you're going to be calculating the other height, right? The y height, or and it's going to be using this equation. Vf squared equals to vi squared plus 2as. From here, Vf is given 1.15.99 squared equals to 2 minus 9.8. And delta s, you can call it, or delta s, you can call it s. This is a distance really. From here, if you calculate the delta y, delta s equals to. So what is the height? If you want to calculate, we're going to take this one and this one and add it together, and then height will be 32.0 plus 13.0 this, and the one is given here. Going to be adding together. So the total height 45.03 meters. This is pretty much what we have in this chapter. If you can have any question, please do reach me out. Thank you. Thank you for watching Knowledge Academy.